All right, today we're going to start chapter 9. All right, chapter 9 is quadratics, graphs, and their properties. All right, first thing, quadratic function is a function that can be written in the form y equals ax squared plus bx plus c. So this is what we were factoring last chapter. All right, here's examples of a quadratic equation. So remember, a quadratic equation has the biggest exponent of 2. All right, so it's to the second power. Remember, we always want to write our problem in standard form. This is going to be very important in this chapter, so if it's not in standard form, we need to reorder it. Right, when we get to our graphs, we're going to talk about a quadratic parent function. All right, that's the most basic graph there is, just y equals x squared. All right, the graph is right here. We will look at them more when we graph. Right, something you should know, all right, very, very important, is this right here. All right, a parabola. All right, a parabola is a U-shaped curve. All right, it's the graph of a quadratic. All right, so parabola. Okay, it says you can fold a parabola into so that the two sides match exactly. This property is called symmetry. All right, so if you look at this graph, right, if we would draw a line right here, we could fold this side over to this side and match up. That's called symmetry. All right, this line is called the axis of symmetry. All right, we are going to find this all chapter. All right, we're going to learn how to find this, the axis of symmetry. Okay, these are things that you should get into your notes. All right, very important. All right, get into notes. All right, you'll need this all chapter. So today we're going to focus on how the graph opens. All right, so this first one, it opens up if A is positive. It opens down if A is negative. We're going to do a little bit today with narrower and wider. So it says the graph gets narrower, all right, if this, remember, is the absolute value. All right, absolute value of the A value is greater than 1. That means the graph gets narrower or skinnier. So if this is our original graph, all right, our second graph would get like this. All right, it'd get narrow. All right, it gets wider if the absolute value is less than 1. All right, so that means our graph will get wide like this. Okay, so that's wider. That's called a vertical shrink. All right, this first one, this is a vertical stretch. Those are also words you may hear. All right, axis of symmetry, x equals negative b over 2a. Very important to get into your notes. We'll find the vertex. All right, vertex is an ordered pair, x, y. All right, so coordinate x, y, and we already have the x coordinate. So we would just plug this in to our equation to find y. And then the y-intercept happens when c is 0, all right, or when x is 0, so it's the c value, sorry. All right, so if you look at this equation, whatever it is, whatever the c value is our y-intercept, because that will be when x is 0. All right, so first page, find a, b, and c, determine if the graph will open up or down. So for every single problem, what we're going to do is we're going to identify A, B, and C. So we're going to go look at the equation, make sure it's in standard form. If it's in standard form, go A equals B equals C equals. So if we look at this equation, it's standard form. So we just put A equals, B equals, C equals. We will do this all chapter. All right, so if we look at this basic equation, A is the number before x squared, so A is 4. B is the number before x, so B is negative 7, and C is just our number, which is 3. All right, so now if it opens up or down, it opens up if A is positive, right? And it opens down, remember, if A is negative. So that's all we look at. So A is 4, it's positive, so it opens up. All right, it opens up. Second one, in standard form, so we go A equals B equals C equals. A is in front of x squared, negative 1/2. B is 1x, and C is negative 4. Next one, there's only two terms, but still it's in standard form, so we still go A equals B equals C equals. All right, so A in front of x squared, negative 5. B is 4 because 4x, and C will be 0 because there is no number out here. All right, number 4, it's in standard form, so we can go A equals B equals C equals. A is 0.8. B, there's no middle term, so 0, and C is negative 3. Okay? Now, for these three, to determine if it goes up or down, remember we look at A. All right? If it's positive, it opens up. If it's negative, it opens down. So negative, so this one will open down. This A is negative 5, so this will open down. A is 0.8, it's a positive number, so it'll open up. Now the last one on this page, all right, notice we should not identify A, B, and C yet because it is not in this standard form. So we should reorder the numbers. So we should rewrite this as y equals x squared goes first, so negative 2x squared, then our x value minus 11x, and then finally plus 7. So now we can say what A equals, which is negative 2, B equals negative 11, C equals 7, and since A is negative, it'll open down. Okay, so now looking at the graphs, this is what a graph will look like, right? So this is a graph that opens up, this is a graph that opens down. So if you notice, right, we are going to have what's called a minimum and a maximum value. So it tells you minimum happens when A is greater than 0, maximum when A is less than 0. I think it's easier just to look, okay? So graph opens up. This right here is the lowest point on the graph. That means it's going to have a minimum. This graph, since it opens down, this point right here is the highest point on the graph, so it will be the maximum. So we're going to determine if it opens up or down. All right, so the highest or lowest point of a parabola is called its vertex. So this is something that needs to be in your notes. The vertex is the highest or lowest point on your graph. We just talked about the minimum and maximum values on the previous page. Vertex is a minimum, all right, when A is greater than 0. All right, and then it's a maximum when A is less than 0. Again, I think it's just easier to look to see how it opens. So if it opens up, this is our graph. This would be our lowest point on the graph. Since it's a low point, this would mean it's a minimum. If our graph opens down, the highest point on a graph, right, since it's the highest point, that would be a maximum. And you can just use min and max. One other thing you're going to need for the rest of this chapter, the min or max value of any graph is the y-coordinate of the vertex. All right, the y-coordinate of the vertex. We'll use that later. Okay, so it says what are the coordinates of the vertex and is it a minimum or maximum? So the vertex is the highest point of the graph, so we just go to find where it changes from going up to down. All right, so this is the highest point right here. So the vertex is an ordered pair. Remember, an ordered pair x comma y. All right, so that ordered pair, the x-coordinate is 0, and then we go up 3, so the vertex is 0, 3. Since this graph opens down, this is the highest point on the graph, so that makes it a maximum. The second graph, all right, this one is opening up. We look for the lowest or the highest point, and that is right here. That is called the vertex. All right, that is the vertex. So if we look, it goes over 1 and down 1, so 1, negative 1. Since it opens up, this is the lowest point, which is a minimum. So I just put a graph on here. All right, this opens down. So we can find the vertex. This is the vertex, so we go over 3, up 8, so 3 comma 8. And since it opens down, this point right here will be called a maximum value. There's no numbers higher than that on the graph. All right? What is the vertex? So very easy. Again, find the highest or lowest point. So this one we go left 2, so -2, down 3. So the vertex is -2, -3. All right, it asks for a max or a min, so it opens up. So this is the lowest point of the graph. This is a minimum. Okay, you can use the fact that the parabola is symmetric. All right, first find the coordinates of the vertex and find several points on this. So this is what we're going to do to graph. So instead of looking at this, we are just going to skip right to this right here. All right, this should go into your notes. I want you to try a couple graphs. All right, try a couple graphs, and we will talk more about our graphs tomorrow. But these steps are very important, so put them into your notes. Step 1, we're going to determine if the graph opens up or down. All right, so if the parabola goes up or down, we've been doing that all day. Step 2, find and draw the axis of symmetry. All right, the axis of symmetry is found by x equals -b over 2a. Okay, and we'll have practice doing that. This is x equals -b over 2a is the axis of symmetry. Okay, it's a vertical line. X equals is a vertical line. Then we're going to find the vertex, all right, put it on our graph. So we're going to plug in x into our equation. Then you're going to make a table. Notice it says only 3 points, all right, that are by the vertex. So this is going to be our vertex value, all right. So today it's always going to be at 0, all right. So this though will always be our vertex, all right. That's going to be our x value of our vertex, all right. Again, today it's going to be 0, all right. And then 1 and 2, unless it's a fraction, right, then we're going to count by the denominator. Then we're going to use symmetry to get 2 more points. Right? Optional step, plot the y-intercept, just gives us another value on our graph, and then draw our parabola, our curved graph. All right, so we're just going to look at a couple of these, and then we will be done. All right, so notice here's an equation, y equals 1/3 x squared. So it's a fraction with x squared. So notice 0 is first, and then we're going to count by 3's because it's 1 over 3. So if we look at this, all right, I'm just going to show you all the values, and then we'll go through a graph the whole way. All right, so if you plug these numbers in, all right, we get y values. And then you can write them as ordered pairs, x, y, x, y, x, y. Okay, then when you graph them, all right, notice, look at, here's your axis of symmetry. We'll find it on the next problem. All of our graphs, all of our points are the same distance away. All right, so this one you count over 1, we count over 1, there's our point. Count over 2, count over 2, we have our point. Okay, we'll talk about the domain and range tomorrow. All right, so let's not worry about the domain and range. Just graph this one, and then you're going to have a few graphs I would like you to try. All right, so this will be probably the last problem we go through. So first thing, determine if it opens up or down. So for that, we need to know what A, B, and C are. So we're going to write A, B, and C. So A is -3. Since we don't even have B or C, we're just going to put 0. So we know this is going to open down. What I like to do is actually draw a little graph. All right, just a reminder, my graph at the end should open down. If it opens up like this, something's wrong. All right, something's wrong. I messed up. Okay, so if we look at our steps, the next thing we want to do is find and draw the axis of symmetry. All right, so the axis of symmetry, all right, I write it like this. This is found by x equals -b over 2a. So again, that's why we wrote down A, B, and C as well. We're going to use them for this equation. So x equals a negative, b is 0, over 2 times a, which is -3. So this says x equals -0, which is just 0, divided by -6. So x equals 0. So we're going to put this on our graph. Okay, vertical line through 0, vertical line through 0. So this is our axis of symmetry. It's going to separate our graph into 2 equal parts. Now we're going to find the vertex. So we have to take this, plug it into our equation. So to find the vertex, we know the vertex is an ordered pair, x comma y. We already have x. So we plug this in, we go y equals negative 3 times 0 squared. So this one's pretty easy. Negative 3 times 0, which is 0. So we have our vertex, 0, 0. All right, this is our vertex. Okay, now the next thing it says, all right, is to make a table with only 3 points are by the vertex. So we're going to make a table, x, y, 0, 1, and 2. We already have 0, right? 0, 0, this is our vertex. Always needs to be first on our table. Now we're going to plug in 1. All right, so we're going to go to our equation. Y equals negative 3 times 1 squared. So negative 3 times 1. So y equals negative 3. Now we're going to do one last time. We're going to plug in 2. So we're going to go y equals negative 3 times 2 squared. So y equals negative 3. 2 squared is 4. So y equals negative 12. So we're going to put those points on our graph. At 1, we're at negative 3. At 2, I'm just going to put it a little below here because my graph doesn't go that far. All right, that's it. Now we're going to use symmetry, so we just count over to our line. So this point, we count to the left, hit our line, so we got to go left one more. This one, we'll count over 1, 2, so we count over 1, 2, and notice now our graph is symmetric, the same on each side. Then you're just going to draw your curve. Right? And the skinnier it gets, the more V looking it looks, okay, but it should be a U, all right? But don't just draw straight lines. Try to make it curved, all right? And that's your graph, all right? So we're going to look at this tomorrow. So I want you to try to do these problems. Do your best. We're going to take number 16 off, all right? Numbers 1 through 4 are graphs. All right. Good luck.